Good morning, students. I'm Suneetha, Assistant Professor of Chemistry from KGC Hanamkonda. And today we are going to continue the yesterday's topic, that is second unit, Organic Chemistry of first semester BSc. There we discussed the structural theory in organic chemistry, that is the first topic. The structural theory, yesterday we discussed about different types of bond fissions and types of covalent bonds, and today we are going to discuss about the types of organic reagents. Here in the organic chemistry we come across three types of organic reagents. They are first one is free radicals, second one is electrophiles, and third one is nucleophiles. So there are three types of organic reagents, is it? There, the first one is free radicals, second one is electrophiles, and third one is nucleophiles. So let us discuss about all these organic reagents one by one in detail. First one is about free radicals. So free radicals are the substances, that is either atoms or the species. Species in the sense group of atoms which contain an unpaired electron or single electron or odd electron. So free radicals are defined as the species which contain an unpaired or single or odd electron. These free radicals are generally produced from homolytic fission that we have discussed yesterday. Free radicals are produced by the homolytic fission of the covalent bond present in the organic compounds. And these free radicals are highly reactive because they have odd electron and they are short-lived. Why they are short-lived? Because they immediately combine with some other atom or species to form the compound. Because of that reason, they are highly short-lived. At the same time, they are highly reactive as they have odd electron with them. Next one is about the free radicals. They attain stability by a chemical change during their lifetime. That is, immediately once they are formed, they attain stability by participating in the chemical reactions. Now let's discuss the different examples which we come across for free radicals. There, the first one is atoms like chlorine, hydrogen, bromine, etc. If this chlorine atom contains one electron, that is odd electron or unpaired electron, then it is known as chlorine free radical. Similarly, hydrogen free radical, this one. And this is bromine free radical. Bromine with an odd electron, hydrogen with an odd electron, or chlorine with odd electron. These are known as free radicals. That is atoms with unpaired electron. And sometimes a group of atoms also contain unpaired electron. Example, they are called species. Group of atoms that is known as species. The species like CH3 dot. This is C2H5 dot. CH3 dot is known as methyl free radical. Methyl, methyl, methyl free radical. And this is known as ethyl free radical. This is called ethyl free radical. C2H5 dot. Dot is nothing but an electron. Similarly, sometimes neutral species having unpaired electrons or single electrons also act as free radicals. Neutral species, that is, they do not contain they do not contain single electron. No, they are not the charged species, but in the structure, this is a neutral molecule, but in the structure they contain unpaired electron. Because of that reason, they act as free radicals. Example, NO and NO2. If we consider the Lewis dot formula of NO and NO2, they reveal that they contain unpaired electron. If we consider the Lewis dot structure of NO or NO2 molecule, there we will come across the unpaired electron. Because of that reason, they act as free radicals. So free radicals are the species which contain an unpaired electron or odd electron or single electron. There they are classified into three types. First one is atoms with unpaired electrons, second one is species with unpaired electrons, and third one is the neutral molecules with unpaired electron. They also act as free radicals, we said. And next one is about the electrophiles. The second type of organic reagents is electrophiles. So what are electrophiles? Electron-seeking agents are called electrophiles. Electron-seeking and electron-liking or electron-loving agents are called electrophiles. Here, electro means electron and phile means seeking or liking or loving. The one which likes electrons is called electrophile. Hence, the definition can be given like this. The electron-seeking agents are called electrophiles. And in general, electrophiles are electron-deficient compounds. Electrophiles, they contain less number of electrons than the octet in the valence shell. Because of that reason, they are electron deficient compounds and they undergo reactions with high electron dense compounds as they lack in electrons. Because of that reason, they combine with the compounds or the species having more number of electrons or electron rich compounds. So in general, electrophiles are electron deficient compounds and they undergo reactions with high electron rich compounds. Next one is electrophiles are formed in heterolytic bond fission of a covalent bond. Yesterday we discussed about the types of the bond fission. There homolytic bond fission and heterolytic bond fission. Homolytic bond fission produces free radicals, whereas heterolytic bond fission produces ions. Their positively charged ions are called electrophiles. So electrophiles are formed by the heterolytic bond fission of a covalent bond. Heterolytic bond fission in the sense the bonded pair of electrons they go with any one of the bonded atoms. Because of that reason, what happens? One atom gets the positive charge, the other atom gets the negative charge. So the positively charged ion is known as electrophile. Now let's consider the examples of electrophiles. Here, first of all, let's discuss about the positively charged ions or cations. So the positive ions or cations, they act as electrophiles because they are electron deficient. The positively charged ion, the ion which possesses a positive charge on it, it is electron deficient. Because of that reason, it acts as an electrophile. Now let's consider the examples. H3O plus hydronium ion, Cl plus chloronium ion, Br plus bromonium ion, H plus. Hi, this is proton. NO plus nitrosonium ion, NO2 plus. This is nitronium ion, nitronium ion. So these are all the examples, different examples of electrophiles. So electrophiles are the cations which are electron deficient. That is, these are the compounds or the species or the ions which have positive charge. They possess positive charge and they are electron deficient compounds. Because of that reason, they are called electrophiles. Electrophiles. And next one is positively charged alkyl groups are generally occurred in organic reactions. So here we consider the positively charged ions, but here no carbon is present. But in general, organic chemistry, we come across positively charged carbon compounds. These positively charged alkyl groups, generally alkyl groups, positively charged alkyl groups we come across in organic reactions, and these positively charged alkyl groups are generally known as alkyl carbonium ions or alkyl carbocations. That is, the carbonium ion is nothing but the ion in which carbon bears the positive charge. The ion in which carbon bears the positive charge is known as carbonium ion or carbocation. So examples for this carbonium ions R plus or CO plus. This positive charge should be on the carbon atom. Okay. So example we have given, that is methyl carbonium ion CH3 plus. C2H5 plus also we can give, that is ethyl carbonium ion. Ethyl carbonium ion. So like this, these are the compounds in which carbon possesses positive charge. Because of that reason, they are known as carbocations or carbonium ions. Okay. Let's see the sometimes instead of positively charged ions, sometimes neutral molecules also act as electrophiles. So Lewis acids are electron deficient compounds. Lewis acids are electron deficient compounds. Electron deficient compounds in the sense octet incomplete compounds. They act as electrophiles. They also act as electrophiles. Previously we discussed about the positively charged ions which act as electrophiles. But here neutral molecules, they also act as electrophiles. Generally these neutral molecules are called Lewis acids because they are electron deficient compounds. Electron deficient compounds in the sense the valence shell of the central atom octet is incomplete. That is 8 electrons are not present in the valence shell of the central atom of that species or molecule. Then it is known as electron deficient compound. So sometimes neutral molecules also act as electrophiles. So in these compounds, the central atoms attract the electrons because they are electron deficient. And these are neutral compounds and accept electrons. These are the neutral compounds as they lack in the octet in the valence shell. Because of that reason, they accept electrons. Examples for such type of neutral electrophiles are BF3, boron trifluoride. In the boron trifluoride molecule, boron atom is the central atom. Surrounding boron, 3 fluorine atoms are present. That is, around boron, only 3 bonds are present, 3 covalent bonds are present. That in that sense, so, boron has only 6 electrons in the valence shell. As boron has 6 electrons in the valence shell, it is electron deficient because octet is incomplete. Octet in the sense 8 electrons. But in BF3, in the valence shell of boron, only 6 electrons are present. Because of that reason, it is having 2 electrons less than the octet. That is, it is an electron deficient molecule. Because of that reason, BF3 acts as an electrophile, which is a neutral molecule but acts as an electrophile. Now let us consider this one. AlCl3. Similar structure it will be having the similar arrangement of electrons, and this AlCl3 it also acts as an electrophile, neutral electrophile. And other examples, if we consider this SO3 molecule surrounding sulfur, the central atom is sulfur. Surrounding sulfur, only 6 electrons are present in the valence shell. Because of that reason, this SO3 molecule also acts as an electrophile. Lewis acids are octet incomplete compounds and generally accept electrons. So electrophiles also have the same nature. Because of that reason, all electrophiles are called Lewis acids. These are represented by the symbol. Generally, electrophiles are represented by the symbol E or E plus. E in the sense electrophile. This is the first letter of electrophiles, and sometimes we also represent electrophiles with a positive charge. E with a positive charge. This is about the electrophiles. Next, third type of the reagent, organic reagent is nucleophiles. Nucleophiles. So nucleophiles. Here nucleo means nucleus, phile means loving or liking or seeking. Ishtapadedi. The one which likes nucleus and a positive charge is called nucleophile. So nucleus seeking agents are called nucleophiles. That is, the one which likes nucleus is called nucleophile. Nucleus in the sense generally we know nucleus is positively charged. So the one which likes positively charged center is known as a nucleophile. Next one is, so nucleophiles, they attract a nucleus or positively charged centers. They donate electrons to other substances because nucleophiles, they have excess of electrons. Nucleophiles are formed in heterolytic fission of covalent bond. We have already discussed heterolytic bond fission yesterday. And the heterolytic bond fission, what happens? We will get two types of the ions. One is positive ion and the other one is negative ion. And positive ion is called electrophile and negative ion is known as a nucleophile. So what are nucleophiles? We said nucleophiles are nothing but nucleus seeking, nucleus loving, nucleus liking reagents. So nucleus seeking agents are called nucleophiles. This is the definition we can give. And so nucleophiles, they generally attract a nucleus. Nucleus in the sense the positive center or positively charged centers. Generally, these nucleophiles, they have excess of electrons. Because of that reason, they donate electrons to other substances. They have the ability to donate electrons to other substances as they have excess of electrons. Next, nucleophiles are generally produced in heterolytic fission of a covalent bond. We have already discussed about this heterolytic bond fission. Now let's look into the examples of nucleophiles. Examples of nucleophiles. Negatively charged ions or anions. One type of nucleophiles, negatively charged ions or anions. So these are electron excessive and they can donate electrons. So negatively charged ions, generally they possess excess of electrons. Because of that reason, they can donate electrons readily. So these are the nucleophiles which have excess of electrons with the negative charge. Now examples, let us consider Cl minus chloride ion, Br minus bromide ion. Next one is I minus, this is iodide ion. This is hydroxide ion, OH minus, Cn minus. Like this we can give many number of examples as nucleophiles. Any negatively charged ion acts as a nucleophile because of excess of electrons as it can donate electrons. Next one, negatively charged alkyl groups are also called negatively charged alkyl groups. They also act as nucleophiles and they are generally known as carbanions. Carbanion. Anion means negatively charged. Carb means carbon. So carbon containing negative charge. The ion in which carbon possesses carbon bears negative charge is called carbanion. Here let's consider the example. This one. Alkyl carbanion R minus. Alkyl carbanion. This is alkoxide ion. This is carboxylate ion. So carbanion means the anion means negative charge, carb means carbon. So the ion in which carbon bears negative charge is called carbanion. So previously we studied about carbocations in electrophiles. Here we are studying about carbanions in nucleophiles. Nucleophiles, carbon bearing negative charge is known as carbanion. So these are they also act as nucleophiles apart from all simple negative ions like chloride ion, bromide ion, iodide ion, etc. Now next, other examples of nucleophiles. In the other examples of nucleophiles, sometimes neutral molecules in which lone pairs are present on the central atom can act as nucleophiles. So, apart from negatively charged ions, neutral molecules with lone pairs of electrons. Lone pair means the pair of electrons which does not participate in the bond formation is called lone pair. So, the neutral molecules in which lone pairs are present, they also act as nucleophiles. So, excess of electrons are present in that molecule. Therefore, it acts as a nucleophile. So, in general, they are octet complete substances. So, in neutral molecules, they are having completely filled octet, but a pair that is a lone pair is present which is not participating in the bond formation. Because of that reason, that lone pair is available for the donation. Because of that reason, these neutral molecules with lone pairs, they act as nucleophiles. So hence they donate electrons to other substances as they have excess of electrons. And the following types of substances act as nucleophiles. So what are the different types of substances that act as nucleophiles? Let us see. So, neutral molecules in which lone pair of electron is present on the central atom act as nucleophiles. So, neutral molecules with lone pair. Now, let's see the example. Here is the example H2O. On oxygen atom, two lone pairs are present. So, whenever we say only one lone pair is enough, then it acts as a nucleophile. Here in ammonia, nitrogen atom contains one lone pair, therefore it acts nucleophile. Similarly, ROH is nothing but alcohol. In this, oxygen has two lone pairs of electrons, therefore it acts as a nucleophile. Similarly, ROR is the general formula of ether, so you know, I think. So here the central atom is oxygen. On oxygen, two lone pairs will be present. Because of that reason, this ether also acts as a nucleophile. So these are all the neutral molecules. These are all the neutral molecules in which the central atom of these molecules, it possesses either one or more than one lone pairs of electrons. Because of that reason, these molecules, they act as nucleophiles. So what are all the examples we said? Water molecule, ammonia molecule, alcohols, ethers, etc. They act as nucleophiles, which are neutral molecules with lone pairs of electrons. Next, generally we know that electron pair donors are called Lewis bases. Electron pair donors are called Lewis bases. Therefore, nucleophiles are also electron pair donors and hence they are called Lewis bases. We just now studied their electrophiles are Lewis acids, we said, because Lewis acids are the substances which accept electrons or electron pairs. Lewis bases are the substances which donate electron pairs. So here nucleophiles are the substances which are electron pair donors. Because of that reason, they are known as Lewis bases. Electrophiles are Lewis acids and nucleophiles are Lewis bases. This point we should remember. They are generally represented by these nucleophiles are generally represented by either Nu or Nu minus. Nu nucleophile or Nu minus also used to represent nucleophiles. So, what are the different types of questions we come across uh, in this topic that we will discuss later? Before going to that, let's revise what we have studied today. So, yesterday's topics continuation. Today we are studying types of organic reagents. Yesterday we studied about the types of covalent and types of bond fission, that is homolytic fission and heterolytic fission. Then during the fission of the chemical bond, we came across different types of radicals and ions produced. So those ions and radicals produced during the fission of a covalent bond are known as organic reagents. These are called organic reagents. So here we are going to discuss about different types of organic reagents. Their organic reagents are of three types, we said. Organic reagents are classified into three types, we said. So how many types of organic reagents are there? Three types. Three types, namely free radicals, electrophiles, and nucleophiles. Free radicals, electrophiles, and nucleophiles. What are free radicals? Free radicals are the substances or the species which contain an unpaired or single electron or odd electron. This is also called odd electron, are called free radicals. So the substances or the species which contain an unpaired or single or odd electron are called free radicals. Now, generally, free radicals are produced by the homolytic fission. We said, what is homolytic fission? Homolytic fission is nothing but the fission of the symmetrical fission, symmetrical breaking up of a covalent bond in which the bond pair of electrons goes with both the atoms involved in the bond formation. That is, if we consider a molecule, both the A atoms get one electron each during the fission. Then we get the free radicals that we have discussed yesterday. So these free radicals, as they contain odd electron or unpaired electron or single electron, they are highly reactive. When they are reactive, their lifetime is less. That is, they are short-lived. That is, free radicals, they attain stability by a chemical change during their lifetime. That is, once they are formed, they immediately react with some other reagent to become stable. This is about the free radicals. Next, what are the different examples of free radicals? Free radicals. So, these are of two types. First type is atoms. Atoms like chlorine, hydrogen, bromine, oxygen, etc. They possess an unpaired electron. Then they are known as the free radicals. This is chlorine free radical, hydrogen free radical, bromine free radical, oxygen free radical, like this. And the species, sometimes the species like species in the sense a group of atoms. This is a single atom having an unpaired electron is a group of atoms having unpaired electron. That is CH3 dot methyl free radical, C2H5 dot ethyl free radical, like this. And next one is neutral. Sometimes neutral species also act as electrophiles. We said their example NO and NO2. NO and NO2. So if we consider the Lewis dot formula of NO and NO2 molecule, we will come across the unpaired electron present in these molecules. Thus, they act as free radicals. So next, second type of um, reagents, electrophiles. Second type of reagents, they're electrophiles. So what are electrophiles? We said electrophiles are electro means electron, phile means loving or liking or seeking or ఇష్టపడేది. So electron seeking agents are called electrophiles. In general, electrophiles are electron deficient compounds, we said, and they undergo reactions with the high electron rich, electron dense or electron rich compounds. So as they contain less number of electrons or electron deficient compounds, they generally combine with the electron rich compounds, or some simply we can say that nucleophiles or negative ions. Electrophiles are generally formed during the uh, homolytic bond fission produces free radicals, we said. So electrophiles and nucleophiles generally produced by the heterolytic bond fission of a covalent bond. Heterolytic bond fission, it produces positive and negative ions, and positive ions are called electrophiles. Next, what are the different examples of electrophiles? Electrophiles, positively charged ions or cations, all they come under electrophiles. So positive ions or cations, they act as electrophiles because they are electron deficient. Electron deficient in the sense they do not possess octet in the valence shell. The central atom does not possess octet, that is 8 electrons in its valence shell. Example, H3O plus, Cl plus, Br plus, H plus, NO plus, NO2 plus. What are the names given to them? H3O plus is known as hydronium ion. Generally, you should remember whenever the name of the ion ends up with IUM, then it is known as positive ion. Yeah, hydronium ion, ammonium ion NH4 plus, you know that. Okay, so this is Cl plus chloronium ion, Br plus bromonium ion, H plus, this is proton, it has a specific name. Here NO plus nitrosonium ion, NO2 plus is nitronium ion, So these are the positively charged ions which act as electrophiles. Next, positively charged, if whenever a carbon bears a positive charge, positively charged alkyl groups are generally occurred in organic reactions, and these are generally called as alkyl carbonium ions or alkyl carbocations. Carbo means carbon, cation means positive charge. That is the species in which carbon bears the positive charge. Carbon bears the positive charge is called carbocation, or simply it is known as carbonium ion also. Em means positive charge. Carbon with positive charge, carbonium ion. Example R plus, alkyl carbonium ion. Here specific example we have given methyl carbonium ion, CH3 plus. Similarly C2H5 plus, uh, C2H5 plus, isopropyl carbonium ion, methyl carbonium ion, ethyl carbonium ion, tertiary butyl carbonium ion. Like this we can give many number of examples where carbon bears the positive charge. Next. Examples of electrophiles. Other examples of electrophiles. Second type of examples, they are the neutral electrophiles. These are also called Lewis acids because they are electron deficient compounds. Electron deficient in the sense they do not possess octet or octet incomplete compounds. They act as electrophiles. So some neutral molecules in which octet is incomplete, they also act as electrophiles. We discussed. So in these compounds, the central atom attract electrons because it is electron deficient, and these are neutral compounds and accept electrons. Example, here we discussed about BF3, AlCl3, FeCl3, SO3, RCOCl, all these are electron deficient compounds because their octet is incomplete in the central atom valence shell. Thus, they act as Lewis acids. Lewis acids are electron pair acceptors. So, all electrophiles, they act as Lewis acids because they accept electron pair. And generally, electrophiles are represented by either E or E plus. Generally, we use E only. Sometimes here and there we also come across E plus. Next, nucleophiles. Nucleophiles, what are nucleophiles? We said nucleo means nucleus, phile means loving or liking or seeking. That is the one which likes nucleus is called nucleophile, we said. And the nucleus seeking agents are called nucleophiles. This is the definition given. So nucleophiles, they attract nucleus or positively charged centers. So nucleophiles, they go towards the positively charged ions or positively charged species. And these nucleophiles, they donate electrons to other substances. Nucleophiles are formed in heterolytic fission of a covalent bond. We have discussed already. Heterolytic bond fission produces positive and negative ions. Positive ions are called electrophiles and negative ions are called nucleophiles. Next, examples for nucleophiles. Here, different types of these examples are classified into different types. There, the first one is negatively charged ions or anions. Negatively charged ions or anions are act as nucleophiles. Simple examples we can give: chloride ion, bromide ion, iodide ion, hydroxide ion, cyanide ion. Generally, these are the all simple negative ions. They act as nucleophiles. These are all electron excessive species and they can donate electrons. Next one, negatively charged alkyl groups are called carbanions. Here in the above example, no carbon is present, but carbon is not bearing negative charge, whereas in these examples, in the following examples, what happens, the carbon bears the negative charge, that is known as carbanion. So carbon bearing negative charge is called carbanion. Example is R minus. R minus is alkyl carbanion. And next Sometimes neutral molecules in which lone pairs are present on the central atom can also act as nucleophiles. So, neutral molecules with lone pairs of electrons, that is excess electrons if they possess, because of that reason they also act as nucleophiles. In general, they are octet complete substances. In these molecules, octet is complete. Then also they act as nucleophiles because they have lone pairs of electrons. What is lone pair, we said? Lone pair is nothing but a pair of electrons which do not participate in the bond formation. The pair of electrons which do not participate in the bond formation is known as lone pair. Then what is bond pair? Bond pair is the pair of electrons which participates in the bond formation. Okay. So in general, these are octet complete substances, hence they donate electrons to other substances. So these nucleophiles, they donate electrons to other substances as they have lone pairs of electrons, that is neutral molecules with lone pairs. And different types, what are the different types of examples? So let us see in the next slide. Here, examples. Neutral molecules in which lone pair of electron is present on the central atom, they act as nucleophiles. Example here, H2O. In H2O, oxygen is the central atom which has two lone pairs of electrons. Because of that reason, it acts as a nucleophile, we said. And another example is ammonia. Ammonia, where nitrogen bears a lone pair of electrons, and in alcohols, the central atom is oxygen, where the oxygen has two lone pairs of electrons. Therefore, it also acts as a nucleophile. And next one is ether. In ether, the central atom is oxygen, which has a pair of two lone pairs. Because of that reason, it also acts as a nucleophile. So, if one lone pair is enough to donate, thus it behaves as a nucleophile. So, next one, electron pair donors are called Lewis bases. So, all nucleophiles, they can donate a pair of electrons. Thus, all nucleophiles are called Lewis bases. Lewis bases. Whereas electrophiles are Lewis acids. Whereas nucleophiles are Lewis bases. This point we should remember. Next, the nucleophiles are also electron pair donors and hence Lewis bases. Electron pair donors are called Lewis bases. Here nucleophiles are donating electron pairs, thus nucleophiles are Lewis bases. So they are generally represented, nucleophiles are generally represented by either Nu or Nu minus. Most of the times we use Nu only, and here and there we also come across Nu minus symbol for nucleophile. Next. So, what are the questions we come across in this topic, what we have discussed today? That is, today we discussed about the types of organic reagents which are very much useful in the organic chemistry. This Here we discussed about three types of organic reagents. They are free radicals, electrophiles, and nucleophiles. So, what are the different questions we come across in our assignment examinations from this topic? There, the first one is discuss about the free radicals with suitable examples. So, we should write about the definition of the free radical. What is a free radical, how it is produced, how it is denoted, and what are the different types of examples we come across in free radicals, that we should discuss in the first question, which is related to the types of organic reagents. Next one is, what are electrophiles? What are electrophiles? Explain their types with an example each. So, electrophile definition we should give, and how it is denoted, and in which type of bond fission electrophiles are produced, that we should see. At the same time, how many types of electrophiles are present, that is positively charged ions and sometimes neutral molecules with Positive neutral molecules also act as electrophiles as they are electron deficient compounds. Like this, we should give example BF3, LCl3, SO3. Certain examples also we should give. So, what are electrophiles and explain their types with an example each. So, here we should write about electrophile definition, how it is denoted, and in which type of bond fission electrophiles are produced, and how many types of examples are there, and for each type mention the type and give few examples. Last one is about the nucleophiles and their types. Nucleophiles and their types with suitable examples. So what are nucleophiles? We should discuss. Nucleophiles means nucleus seeking. That is the one which likes nucleus. The one which likes positive charge is called nucleophile. Like this example we should write. Then what is nucleo? What is phile? Nucleo means nucleus. Phile means loving or liking or seeking. The one which likes nucleus is called nucleophile. The one which seeks nucleus is called nucleophile. Like this definition you should write. Followed by how many types of nucleophiles are there? What are the other name given to nucleophile? And how nucleophiles are represented? And in which type of bond fission nucleophiles are produced? All this comes under explanation about the nucleophiles. Then we should write the types of nucleophiles. Types: negatively charged ions and sometimes neutral molecules with excess of electron pairs, that is lone pairs of electrons. Like this we should mention. Similarly, carbon ions also they come under nucleophiles. All these steps we should mention in this question. So explain nucleophiles and their types with suitable examples. There we should write all the information which we have already discussed. So today's topic is second unit organic chemistry. There the first lesson is structural theory in organic chemistry. And what is structural theory? We discussed yesterday. What is structural theory? Structural theory is nothing but which explains the basic organic chemistry. Then why we are supposed to learn about organic chemistry? We said because organic chemistry is a part of our life, as it is a part of our life. And today we live in the age of organic chemistry. The three basic needs of humans are food, clothing, and shelter are made up of organic compounds. Because of that reason, we should learn about organic chemistry. And there, to learn about organic chemistry, structural theory in organic chemistry is the basics. So we are learning structural theory in organic chemistry. In the structural theory in organic chemistry, generally carbon compounds, uh, we learn about carbon compounds. Carbon compounds generally carbon generally forms covalent bond, we said. And so types of covalent bonds we discussed yesterday. There are three types of covalent bonds: single, double, and triple covalent bonds. After that we discussed about how the covalent bond is broken to form the new compounds. So in the existing molecule, the covalent bond must be broken, and this breaking up of the bond in the existing molecule is only called bond fission. And two types of bond fissions are present, we said. There the first one is homolytic bond fission, second one is heterolytic bond fission. So homolytic bond fission and heterolytic bond fission, they produce different types of radicals and ions. In homolytic bond fission, free radicals are produced, and heterolytic bond fission produces positive ions and negative ions. Positive ions are called electrophiles and the negative ions are called nucleophiles. So all these free radicals, electrophiles, and nucleophiles, they come under uh, types of organic reagents. Types of organic reagents. So today we discussed about three different types of organic reagents. They are: first one is free radicals, second one is electrophiles, and third one is nucleophiles. So, what are the different types of questions to be asked in the examination on this topic? We discussed. They are about the first one is about free radicals, Free radicals definition, how they are produced, how they are represented, what are the different types of examples we come across. That one. Second one is what are electrophiles and how they are definition of electrophiles, how they are produced, how they are represented, and how many types of electrophiles are there, and examples for each type. And third one is about the nucleophiles. So nucleophiles, how many definition of nucleophile, then how many types of nucleophiles are there for each type example, then what is the other name and how they are represented, and what is the other name given to nucleophiles, and all these uh, topics, they come under types of organic reagents. Types of organic reagents. So let's stop our topic and let us continue in the next class. So get ready for the next class with the answers of the previous class. So in the previous class, we asked 2-3 questions: types of covalent, how many types of covalent bonds are there, and the examples for each type. Discuss about the each type of the covalent bond. And next question we said we gave, that is uh, types of bond fission. How many, what is meant by bond fission, and how many types of bond fissions are there, and each and every bond fission, that is homolytic bond fission definition and examples, and heterolytic bond fission definition and example. All this we asked in the previous class. So be ready with the answers for the previous class. Okay, thank you all. We will meet in the next lesson, that is continuation of the structural theory in organic chemistry.